Hi students, today we are going to discuss some numerical problems on the topic bodies attached through pulley. You can see a pulley is suspended from a vertical support and a string consisting of two masses M1 and M2 is passing over the pulley. So now the greater mass M2 will be accelerated in the downward direction. And the smaller mass M1 will be pulled upwards and it will be accelerated in the upward direction. And since both the masses are connected over the pulley with the same string, the numerical value of acceleration will be the same. So though the direction of acceleration is one downward and one upward, the value will be the same for both the masses. And also there will be same tension acting on the two portions of the string. So I will read the problem. Two blocks of masses 2.6 kg and 4.1 kg are tied together by a light string passing over a smooth frictionless pulley. What will be the acceleration of each mass? What will be the tension in the string if G is taken as 10 meter per second square? Now first we will try to solve by equation method. Then direct formula method also is there. Okay, let us learn how to do this problem. Now you see on the right hand side is mass M2 and the left hand side there is mass M1. So if I draw the free body diagram for the mass M1. So this is the dot which represents the mass M1. And you see here the weight M1G is acting in the downward direction. And the tension T is acting in the upward direction. And the acceleration also is acting in the upward direction. So for this, if I will write the equation of forces, T is acting upward. So T minus M1G, that is equal to M1 into A upwards. So M1 into A upwards. Now what is the tension we have to find out? Acceleration also we have to find out. Only M1 and G I am going to substitute. So T minus M1 is the smaller mass. So the smaller mass is taken as 2.6 kg. Okay. So this is a 2.6 into G. So this is equal to M1 into A. So this is a 2.6 into A. And this is our equation 1. Similarly, the free body diagram for mass M2. So the free body diagram for mass M2. So M2G is acting in the downward direction. And T, the tension is acting in the upward direction. And this time the acceleration also is acting in the downward direction. So this is M2A. So if I will write equation T is upward, M2G is downward. Okay. So I will write it T minus M2G. So this is a T minus M2 into G is equal to minus M2A. So this is minus M2A. I will multiply by negative sign on both sides so that this can be written as what? M2 into G minus T. This will become positive. So this is M2 into A. Now I substitute the values M2. So M2 is equal to what? 4.1 kg. So 4.1 into G minus tension T. So this is minus tension T. This is equal to M2 into A. So this is 4.1 into A and this is equation 2. So now I am going to add equations 1 and 2. Okay. Adding equations 1 and 2. So first let us add the left hand sides. T minus 2.6 into G. So T minus 2.6 G plus 4.1 G minus T equal to 2.6 A 2.6 A plus 4.1 into A. Now T minus T get cancelled and 4.1 minus 2.6 into G. So 4.1 G minus 2.6 G, and this is equal to 2.6 plus 4.1 is 6.7. So 6.7 A. So 6.7 A is equal to 41 minus 26. 41 minus 26. So 41 minus 26. So this is equal to 14. 15. Okay. So this is equal to 15. So 30, 36, 41. Okay. Now therefore A is equal to 15 divided by 6.7. So let us use the calculator now. 15 divided by 6.7. So this is a 2.2 meter per second square. So we have got the acceleration as what? 2.2 meter per second square. Now if you substitute the value of A in any one of the equations 1 and 2, you will get the tension. Okay. So I am going to substitute A in equation 1. So what is this? T minus 2.6 into G. So T minus 2.6 into G is 10. So this is equal to 2.6 into A. So T minus 26. T minus 26 is equal to 2.6 into 2.2. So this is equal to 2.2. So 2.6 into 2.2. So this will be equal to 5.72. Therefore, tension is equal to 5.72 plus 26. So this is 26 plus 5, 31. So 31.72 Newton. So this is the tension in the string. Okay. Now by formula method, if you want to find the acceleration directly in competitive exams, you can substitute the values, isn't it? So by formula method, if you go means the acceleration is equal to the greater mass m2 minus the smaller mass m1 divided by the sum of the masses m1 plus m2 into g. Okay. So directly if you go by this method also, you will get the answer. So this is now equal to what? M2 is 4.1. So 4.1 minus 2.6 into G is 10 divided by the sum of the masses 4.1 plus 2.6. So 4.1 minus 2.6 is 1.5. So this is 1.5 into 10 divided by 6.7. So this is equal to 1.5 into 10 is 15. 15 divided by 6.7. So this will be equal to 2.2 meter per second square. So we will get the same answer only. One is direct method. So another formula for tension directly, if you want, means tension is equal to 2 times m1 into m2 divided by m1 plus m2 into g. So if you substitute the values for m1 and m2 means you will get the same value only. Okay. Then one more formula is there. If the two tensions acting on the strings react, so what will be the reaction to the tension in the two strings? That also can be found. So the reaction force due to tension, okay, the reaction force due to tension R is equal to T plus T, that is equal to 2T. You can substitute for T and find that also. I hope you must have understood well. Fine.